Hello everyone, welcome back to Advent of Code. Today is day 8, so we're going to be doing day 8 of 2023, but as I often but not always do, I will start today by reviewing some changes I made to the previous day's solution, while I had some time to sit and simmer with it. This time these improvements are mostly not of my own creation. Someone in the Stack Overflow, what am I saying? In the functional programming Discord, posted a solution. And I've seen a few of her solutions before, and I was like, wow, someone else is using text regex duplicative. Are you kidding me? Nobody uses this thing, but and then I looked at her solution to day 7. It's like it's a lot like mine, right? She actually goes to the work of defining this big type, and ended up having to make a new type wrapped around it to use a different compare. She did it better than I did. I think this is perfectly fine. I'm not changing this. What I wanted to go back and look at was the two things that I thought were the most, blatant, pointless duplication in my previous solution, because I didn't really think of a good way to fix them. That were, downsides of defining the right type. And those are the parser value here and the hand parser here. The value parser, I don't know. It's basically... I was thinking, all right, we're going to have to write out the names of all the types, of all the constructors. And we're going to have to write out, a symbol parser for each of the symbols we're parsing. And so, what better thing is there to do than just write them all out? But there is something better, which you'll see in a moment. Which I don't remember... I'm sure it's not exactly like what Melissa wrote. I copied some of the idea, but I wasn't looking at the code exactly while I did it. But the one that I thought was cutest was the improvement for hand here, which of course we're looking at the old version now. We'll get to the new version in a minute. Is the kind of thing that I would like to be able to spot myself, because the upside of this hand type is that, compared to the obvious thing of having a list and parsing it into a list of... So instead of, parsing a list of arbitrarily many things and then checking that it has size 5, we have a type-safe proof that there are 5 things. There can't be any other number. The downside is we can't just, say, replicate value 5 times, right? Because there's no list to replicate them into. There's this hand thing instead. And so let's now look at the new version. Hello? What happened? That's not right. How did somehow it ended up reloading the old... I'm on main. Somehow I've got exactly the previous... Okay, fine. I guess I want to check out. Okay. I guess I won't... No, I wanted to get checkout. There we go. Updated. I know I could say reset hard, but that's... Get checkout... Oh, not dot. I'm in tomorrow's directory already is the problem. Okay. There we go. So throw away those changes that I accidentally made in Emacs. Reload this. Do not bother me about the dang LSP that doesn't even fucking work. I should take that out of my hooks or something. Anyway. So look how much nicer hand is now. We can... A thing that I did not do, that I think I might have mentioned, but it ended up not doing, was I said, if hand needs to be applicative, we can derive that. And I didn't ever see a reason for hand to be applicative. But it turns out it is useful for hand to be applicative. So first we'll talk about what it means for hand to be applicative and how to make it happen, and then why that's useful. So when you have, I've talked some in some previous episodes of this year, I don't know which ones exactly, about how like when you have a product type like this that's just got one type parameter, isn't it nice for it to be applicative? Because, you know, sometimes you're going to want to put functions in here and like who knows what. And you might want to combine two hands in some arbitrary way, and if they're both applicative, that's very easy as long as what you want out is another hand. So to be applicative, you need two things, and I've commented out here what would be a valid applicative instance for hand. You need pure, which is a way to take a value of type A and make it into a hand of type A. And that just means, well, we're going to need, there's only one A lying around, we're going to have to use it 5 times, so it looks like this. And then you need either this, which, I don't know what people call this, I call it app because it's the same thing as the monad function named app, but just like they invented app before they invented applicatives, and so they had to give a different name to the applicative version. You could alternatively you could implement lift A2 and they're equivalent. But it says if you have a hand of functions and a hand of values, how can you combine those things to get a hand of the functions applied to the values? And so it's pretty straightforward. You just take 5 functions and 5 things, and you point-wise apply the functions, and you turn the result into a hand. However, this is commented out because, like, this is such a fucking pain to write, isn't it? And it turns out GHC can derive applicative for you for simple product types like that. The same way it can traversable, foldable, show, eq, all this stuff. Via... This requires more language extensions than the rest of the stuff I'm using. We need deriving via in addition to all the stuff that comes in with GHC 2021. And we also need to import GHC generics to get... Actually, do I need all of these imports? I don't know because I've already... I'm not going to mess with it. I've already updated... I've my... I mean, maybe I will try it. Okay, so currently we just get a warning. Oops. But do I need... I assume I need those, don't I? Yeah. We need the constructors in scope for deriving via to know how to do it. So generic 1 is this type class that GHC has for a second order type, I think is what it's called. A rank 2 type? Maybe? I don't quite know what the right word is for the kind of thing that hand is. Like, it isn't just, like, you can't, it has a type argument, is what I'm saying. And I think that makes it maybe a second order type, but I'm not sure. Generic is a type class for, you know, concrete data types with no parameters, where GHC basically says, you know, generic is the type class for a way to express this type in terms of sums and products, without, you know, generic, like, A or B and A and B, like those together are enough to model, you know, most/all Haskell data types. You need recursion as well, of course, but other than that. And so generic is the type class for, sure, I can convert my thing to a generic sum and product representation and back. And GHC will derive that for you. You can't do that for hand because, like, it has this type parameter, and so you need A to also be generic. I think, maybe? I don't know. I guess you don't, right? Of course not. I don't really know what generic 1 does, but it's a type class for types shaped like this to participate in the generic machinery. So we need GHC to derive that for us. And then we're allowed to say, I want to derive applicative for this type. And the mechanism for doing it is to convert via generically 1 of... To convert, you know, generically 1 of hand and back. So this is sort of like writing instance applicative hand where pure of A is from generic of to generic, or I mean, I guess we could say, I don't know what the constructors are called, but of pure A, I guess, because you don't have to go from and to. So there's some generic type that you can say, I'll make a pure, and like it can use generically one to like have a pure that's not related to hand, and they say, oh, convert that back into my type, sort of, and you could do something similar with that. So by some magic, it like applies a new type wrapper, does the work in generic land, and then unapplies the new type wrapper to get back to you, and that's kind of what via does. So you can, if there's some type that's isomorphic to yours as a new type, and that type has an instance you want to borrow, you can say, oh, just like apply the new type wrapper, do the thing, and then unapply the new type wrapper, and that's what deriving a via does. So that's how we get applicative for free without having to actually write it for hand. And having that, we can do this. What is sequence A of pure value, really? Well, value is a parser for value, and pure, working in the hand applicative, is a hand where all 5 things are the same. We just talked about that, right? In this case, they're all, I have 5 parsers for values. So it's the same as hand of value, 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 right? Sequence A works in applicatives and traversables. I don't think it needs foldable, right? Anyway, and it takes a, let me get this right. An applicative, no. It takes a T of F of A and makes an F of T of A? I always forget. Where T is the traversable and F is the applicative. I mean, what it's making is a parser. It's turning a hand of parser of value into a parser of hand of value. Right? It's applying this transformation. Is parser the applicative here or the traversable? It's the applicative, right? Hand is the traversable, I think. They're both applicative, of course, but hand is being used as a traversable, while parser is being used as an applicative. Yeah, that seems right. Anyway, so that's the improvement to hand. And we already looked, I think, at the... Oh, no, we didn't. Did we? I mentioned it, but we didn't really look at it. So here's the new parser for value. Instead of writing out each constructor by hand, write out the order that you want the characters, and you can make that very short because a bunch of characters is just a string. And then, as long as you give the card, what do we call it, value type, an enum instance, you can just write this, saying like the first one and then on up to the rest. So this is much less explicit than what we did before, but in some sense more flexible. Like if we ever add a super ace, as long as it, you know, well, no, I guess it will never. This will still need updating because yeah, I don't know. I don't think either is more or less maintainable than the other, but this one's certainly more pleasant to write. And so we just zip the list of this together with the list of this and apply this function to create a parser out of each and combine them together. I think there must be something better than asum combined with zip with, but I don't know. Anyway, let's just make a small change here to remove the commented out thing. There you go. So that's this person's GitHub account, by the way, if you want to go look at that. I don't think I saw Advent of Code Solutions on there. She may not be posting them. I don't know. Maybe they're private. So let's finally move on to day 8 here. Yes, 8. Day 8, Haunted Wasteland. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled Maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the document seems to describe some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. What about the sandstorm? Are we not worried about that? Is it a ghost sandstorm? After examining the input for a bit, the maps for a bit, two nodes stick out, AAA and ZZZ. You feel like AA... I just have some mystic sixth sense about how to interpret maps and Dead Reckoning. Okay. You feel like AAA is where you are now, and you have to follow the left-right instructions until you reach ZZZ. This format defines each node of the network individually. For example, RL? Okay. AAA is BBB CCC? What? What does that mean? Starting with AAA, you need to look up the next left-right instruction in your input. In this example, I see. Start with AAA, and then go right, R, I guess because it starts with R here, by choosing the right element of AA, which is CCC. Then L means choose the left element of CCC, which of course is ZZZ. By following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. RL really means, repeat it forever. For example, here's a situation that takes 6 steps to reach ZZZ. L is B, L is A, then R, which is B. Now back to L, L, R. Okay. Well, this seems relatively straightforward, yeah? What are we counting as a step? A step is... being at a node and going to either its left or right node. And so the last step includes stepping to ZZZ from wherever you are. That counts as a step. It's not like when you're here applying R, you're done, and you did it in like 5. The last R, the one you took to go here, that's the 6th. And okay. Okay, sure. Long input. Definitely not going to figure this one out by hand. Huh. Well, we know we'll have to get to SKV at some point while looking right. I sort of dread to think what part 2 is going to be. Oh, this... we should be in day 8 now. Okay. And it's got this list of 271 instructions. I mean, I think it could be possible that this would take such a long time to run that you need like some other plan, but I don't think so. Right? Like probably just doing the dumb simulation is supposed to be good enough today. Right? Nothing ever sends us back to AAA. So, like, I don't know. There are 816 nodes we could be at, right? So how many total states does this machine that we're exploring have? 816 times 271. I mean, that's like 24,000 or something, 240,000, something like that. Way, 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 way less than our computer is going to have trouble processing. So the state either has to loop or finish within, 300,000 iterations. Maybe it's 30,000. I don't know. Math is hard. We have like, right? Anyway, the point is, just doing the dumb looping should be good enough, at least for part 1. And I can't even begin to imagine what part 2 is going to be, but I assume it's going to apply L and R means something different somehow. Since they foreshadowed in the problem that we're just guessing at what we're supposed to do. Almost anything could be what we actually have to do. So, let's define some types and write some imports. Definitely need a map, and we might as well be strict. I don't imagine we'll need anything lazy here. Gonna need a... Do I even need a node? I think our node is just a string. Well, it's a label, right? Like... So I think what we have is like a map whose keys are nodes and whose values are choices. Right? That makes sense to me. We need a data... Well, do we even need a data type for this necessarily? Obviously we don't. I was going to define data L or R, right, for a direction. And obviously we don't need one. You could use almost anything. I like defining types, and I will give this a type, but like maybe it would make sense if what this really were a function from choice to node, and left and right were just two values in that. Actually, here's a funny thing, right? Like, let's just talk about this for a minute. Suppose we said data direction equals left or right. Actually, we would use L or R to avoid conflicting with either's definitions. So that's a thing you could do. There are clearly, with this scheme, there are two different directions, and you can pattern match on them, and like, wouldn't that be lovely? What about this type that I wrote? Call it a selector. Is a function how many different selectors exist in the universe? It takes a tuple of two A's and returns an A. How many different selectors are there? I know the answer. I'm trying to give you a second to think about it. Pause the video if you'd like to think more, of course. And I've asked some leading questions, but of course the answer is 2. There are only 2 selector functions in the whole universe that you could write. You're gonna have to pick one of the 2 A's, and there's no way for you to like flip a coin because you're not in I/O or something. You can't go look up some field in some other structure, or if you do, that structure has to be the same all the time. And so it comes down to either you always choose left or you always choose right. And so in some sense, like, this is also a perfectly reasonable definition of a direction type, right? This isn't true for specific A's. If I said, how many functions with this type are there? You would say, like, well, I mean, okay, it would be like, max bound of int squared raised to the power of max bound of int. Like, that's how many functions there are that could have this type. A lot. Right? 2 to the 64th squared, I guess, is 2 to the 128, and then raise that to the power of 2 to the 64. It's just enormous how many functions there are of this type. But because of parametricity, you know, in a function taking 2 ints and returning an int, you could do whatever you want with the ints. To define a function of this type, you know, maybe we should be more explicit and say it's this. But that's sort of implied. If we had said direction of A, like how many functions are there of type direction A? Who knows? Lots. Because direction of int is a thing that exists and there's zillions of those. But if we say direction has to work no matter what A is, then when implementing direction, you can't look at the you can't do anything with the tuples because you don't know what they are. All you can do is just say, well, I'll pick the left one or I'll pick the right one. So this is an equally valid definition of direction that just sort of strikes my fancy today. So we'll stick with this. I think it's going to be a bad idea. It'll be totally fine for part 1. Because the only thing we'll have to do with a direction is apply it to tuples of this type. And that's perfect. Well, except I don't want to apply it to tuples, right? I want to apply it to choice nodes. There you go. Easy. Now instead of tuples, it applies to choices. You could also say, like, A to A to A. That's the same thing. We'll say a direction... Oh, let's call it a preference. There you go. Wouldn't that be silly? Our preference... I don't know. What am I doing, man? Let's just write direction for now, and we'll let the way the code turns out / what part 2 turns out to be tell me whether that was a bad choice or not. We have a good type system. The compiler will tell us if we're like if I decide to refactor it by changing the name. In a small program like this, the type system will have no trouble helping me find the right places to fix it. So, let's say our type, a type for the map we're going to have from node to choice of node. It's a map, but what do we call it? The problem is the problem statement also says it's a map. But they mean like a two-dimensional map of the world, not a mathematical map. We'll call this one an atlas again. We did that previously, didn't we? Atlas. Should I try to be generic here, or should I depend on specifically node? I think I should depend on specifically node. Is an m.map from node to choice of node. Out of curiosity. Okay, I wondered if GHC 2021 might include type operators. I never use type operators. I don't know if you can even do that, but I don't know. It would be nice to not need these parentheses. So that's our atlas type. Let's get text regex applicative now. My parser of choice as always. And we won't need numeral or decimal for a change. We want RE, we want sim? Let's take string at least. I don't think we'll need sim. Let's just use string. We're going to need match. I almost like... Well, no, I guess I need psim, right? I mean, I could use any sim, really. But I think psim is more... So one question, I guess. that we could ask ourselves is, this input format uses 3 letters for the node names. Uppercase letters, even. How much of that do we want to depend on? Do we want to depend on them being exactly 3 long? Do we want to depend on them always being letters? What if, obviously it's just advent of code. We know the answers are all like this, but like, what is kind of the most faithful representation of the problem statement? How much of it we hard code and how we hard code it is sort of up to us. The problem statement just says there's a network of labeled nodes, left-right instructions, maybe, nodes A, and ZZZ, each node. Like, it doesn't tell us anything about the format of a node. They just say there are nodes, A, and ZZZ are 2 of them, and this is what your file looks like. So really, I feel like the only thing we can conclusively say is that nodes don't have spaces, equal signs, parentheses, or commas in them, right? So that's sort of the most faithful description or interpretation of the problem statement, I think. And it would be kind of nice to be generic enough to handle a slightly different input than the one that we actually have. So yeah, psim seems like a good way to do that. Yeah, okay, fine. And let's define our parser as usual. Let's see. Let's find a parser for direction first. That's gonna be cute, right? Direction is left of... Oh, I actually just want sim, don't I? Sim L. I guess I could have used string here. Or right of sim R. I mean, where do I have to put the parentheses to make you happy? Oh, illegal polymorphic type, huh? I guess that's a fair point. Yeah, so the issue with this definition is that we end up returning... GHC doesn't really like higher rank types very much. There are extensions you can turn on in predicative types, yeah. Like, we could do that. But it's just getting into kind of a big mess for no good reason. So let's just say data direction equals L or R. I shouldn't need eq, really. Well, I'll leave those in parentheses in case I decide to add another one. Choice is certainly going to need, well, show, I guess. Shouldn't need much else, I would think. And then we can just say L R. Oh, don't give me this shit. Or is not in scope. Fine, I'll bring it from here. Let's move these around into an order I like better. Yeah. Now, how many of these parentheses were actually necessary? You know what? I am not fucking with it, because it could accidentally be typed correct, but semantically wrong. Put the parentheses in. I don't understand how precedence works for applicative operators. Better safe than sorry. That's our parser for directions. Let's write our parser for a node. Node is node mapped over some psim of not punctuation. We're going to need a little quick thing here. Punctuation is a function from char to bool. Punctuation is... How do you look in a map and ask if it contains such a key? Member. M.member. I thought it might be. Wants the key first, huh? Flip M.member of... P's. Where P's is... Oh, no, you know what I want to set, actually, not a map. What am I thinking? Data set. Does this exist? I don't know. We'll see. Does set have strict and lazy? I don't think so. That doesn't make sense. Because there's no value to force. S.from list of... We can't allow spaces, equal signs, left or right parens, or commas. So now, those are the only five characters that are reserved for punctuation in the problem description. And everything else is a valid node component. And we're not going to be picky about how long they are either. Fine. So now we have a node. And at this point, well, we can say like choice. Well, no, we have like a line parser for tuple of node and choice of node. Line is a tuple mapped over a node and ignore the string equals and then parse a choice where choice is choice mapped over a node and then ignoring the string comma space and then another node. Does any of this type check? Looks like it does. So the precedence is probably right. I mean, it has to be, right? The choice argument, we somehow came up with two arguments to choice, which are of type node here. And they can only be this one and this one. There's no way we somehow got the same one twice. We're only ignoring one thing, right? Yeah. Okay. And I think we can then say, like, input Oh, you know what? We need a data input this time. It's an input of list of direction and an atlas. And we can say input is a parser for input. Input is input of first some direction and ignoring new line, right? That's how many new lines there are in between here. 1, 2. Yep, okay. Then some m.fromList over some lines each followed by a new line. Anyone with me so far? It doesn't compile yet. Oh, that's because prepare is wrong. We don't really need, we just need like from maybe, no. Yeah, from maybe, error, no parse, composed with match the input, please. This is for org node. Yep, that's true. We do need that. Deriving all the cool shit. Show eq and org. Okay, so this type checks. Great. So let's, as we often do here, try... oh, it doesn't have the history of our previous sessions here? Okay. Read file of input.txt. Prepare that, please. Nothing. No, that doesn't seem right. These must not be showable or something? Yep. No parse. Yeah, so that's not very helpful because I didn't make it possible to help. I mean, we didn't test the parser at all, so that's fair enough. Let's try a few simpler things. Let's try equal some direction of... That looks fine. Let's try to match a node. So this actually... Oh, node lowercase, of course. This actually, I think, should parse. Yeah, this won't be present in the input, but if it were, we would handle it. So that works. How about a line? Let's map that over like... Let's go look at the fourth line of this, maybe. Read file, input.txt. Oh, yeah. Lines, and then get the fourth one. Nothing. Okay, so there must be something wrong there. right? In our line parser. Some non-punctuation. Well, we believe node works. Oh, of course. Our choice. We don't have the parentheses around the tuple. And also our line doesn't have the new line in it? No, I put that here. Okay, sure, I guess that's fine. Now it parses. Okay, and now the whole file parses. Much better. You know, is this correct? We don't have a proof, but it would be difficult to fabricate this data without parsing the file correctly. So part one, I guess. We want... What is a high-level operation to describe what we're doing? Of course, we can just write a recursive function that, like, keeps a current position and a... list of directions. But that's somewhat tacky, right? It's much like a fold. I guess what it is it's a scan L, right? We're scanning over the list of directions, and we're folding that into a position at each step, and we want the intermediate positions to be output, right? And that's what scanl does. Okay, so let's do this then. Part one of input ders and m is going to return an int. We're going to call pred here because I expect the answer to be too high by 1, because scanl includes the initial state, which won't be one of the steps we're taking. Will it? No. Okay. We could have said like drop 1 or something, but pred.length dot take while not equal to node of zzz scanl go of what other arguments does scanl take? The accumulator, which is node AAA at the beginning. Apply that to ders, please. Where go is undefined. Yeah, you're warning me that m. Okay, so this all type checks, but I do have to write go. Go. Scanl takes the accumulator argument first. So go of location and direction is Let... This is a little cheating. We're going to use a partial lookup function, I guess. Let's see. Choice LR equal case. No, equal M dot. No, equal. Location looked up in M. Then in case dir of L R R, and I think that's it, right? Nothing weird going on here. Couldn't match type map of atlas choice of node with node. Did I get the arguments to scanl wrong again? Like a dummy? Arguments to scanl. ABA takes the list of B's, which are takes those second, and it also takes them second here, so this looks right. Okay. Here's the type I think Go has. Go has type node direction node. Now, what do you think this is? I don't know. You're upset that I'm looking up a location, which is a node in the atlas. The input has an atlas, and we said an atlas is a map from node to choice of node. Okay, maybe I'll get a better description from you. Did I get the arguments for m.lookup wrong? Oh, it takes the map first? Okay, I guess I just forgot. Okay. Alright, it was all fine. So I think this makes sense. Start at A, scan the go function over the list of not the directions, but cycle the directions so that they carry on forever. I don't know. Let's see what happens if we run it. Anything good, you think? It's a number. It's always enough to make me happy. 16,530. It's even a plausible number, I think. Too low, though, huh? Is it possible that I wasn't supposed to subtract 1? Let's think about that a little more clearly. So suppose that our very first instruction was to step left, and we looked at our node, and left was ZZZ. Obviously, the answer we should get there is 1. Is that the answer we would get? Take while not equal to ZZZ. Well, there's only going to be 1. Right? The starting node. But then we're going to drop it with pred. So actually, I think the fact that take while doesn't include the final thing that met the predicate exactly makes up for the fact that scanl includes the start when we don't want it to. So I think I can just say this. And then it's like the kind of thing that deserves a comment, but I won't be writing one. Instead, I'm going to record a whole hour-and-a-half YouTube video. Just post a link to that in the comments to explain why this is correct. So if I run this, of course, I'll get the same number plus 1. And I imagine it'll tell me I'm not yet ready to try again. Because I was just so fast at fixing my bug. Oh, sorry. I didn't show you guys. Did you see it earlier? Maybe I didn't even show you me putting in the wrong answer. Sorry. I don't know. Here's the right answer. We did it. Anything in here I don't really want to commit? It all looks fine, I think. Day 8, part 1. Okay, now what we've all been dreading / looking forward to. What on earth is part 2 going to do to me? The sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow the instructions, but you've barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending with A is equal to the number of nodes ending in Z. Ah. If you were a ghost, you'd probably just start at every node that ends with A and follow all the paths at the same time until they all simultaneously end up at nodes that end with Z. Uh-huh. Yeah. So that's tricky. Because, like, obviously we could just run this simulation, right? Run, you know, however many of them there are. Let's find out, in fact. If we search for A space equals... Oh, there's only, like, 6. I thought there might have been, like, 100. And then we would have to come up with something clever, like figure out how long each of the cycles is and, you know, find their least common multiple and shit like that to avoid having to do the simulation a bajillion times. So now how many states are there in our machine, right? I mean, in principle, I think there are, like, a zillion more, right? How many things end with Z? Oops, what have I done? No, don't do that. I moved the... Okay, I don't know how to undo that. Just close this window. And then make a new one? Wait, how do I do that? This? Yes. Okay. I did it. Actually, wait, am I in the right directory right now? I'm not. So how many end with Z, please? 1, 2, 3, 4, 5, 6, 6. Let's just make sure I didn't miss any, shall we? 1. Well, 1, 2, 3, 4, 5, 6, 7. 6 or 7, something like that. 1, 2, 3, 4, 5, 6, 6. Yeah. So that means there are going to be 6 states in our thing, right? So we earlier said there were like 24,000 states that we could be exploring. Now there's something like 24,000 to the 6th power? It's a little bit scary, right? Yeah, that's 10 to the 26th states. That's clearly way too many. But, of course, I mean, we don't know that all of those states are going to be explored. We said there were something like 24,000 states or 240,000 states before, and we explored 16,000 of them. But we can expect the answer to be around 16,000 to the 6th, right? And that's still 2 to the 25th. That's assuming all the loops are the same length. So I suspect that actually the map is designed such that there are like 6 disjoint subsets that these camels go around. Like, it would be much tougher if, like, the path starting at AAA happened to pass through QQA on its way to some Z, right? And then also the path to, you know, XYZ was part of a loop that also went through ZZZ or something like that. That would make things more complicated. If there are just 6 distinct paths, we can measure the length of each of them and then multiply them. Well, get their least common multiple anyway. So it would be nice to verify that first, I think. Rather than just assuming it and seeing, like, if the website tells me my answer is right. Yeah, I mean, what do you do once you get to ZZZ, actually? Yeah, I mean, ZZZ exists. It goes to SHQ or TPN. So there is some sort of loop. There has to be. Well, okay. Either there's a loop or you fall off the edge at some point, but I don't think they would do that to me, and certainly they didn't for the first part. So I think what I'd like to do is write a function called walk that takes an input, a node, and input, and returns a list of node. All the nodes that are ever visited by this walk. And we just won't do any filtering or taking a while or anything. We'll just run it forever. So it's going to be most of part 1, right? Part 1 is... like, we're just going to take this out. And walk is this. Walk from start. Actually, I don't need the input here anymore. So let's just make sure that still works. Yeah, that's the same answer. Okay. So now we can say, do some experimenting. I want to go to GHCI and say take 5 of walk AAA filter lambda of node n is suffix of? Where do I get is suffix of? It's from like data list. So walk from A, and then keep only the nodes ending in Z, and give me the first 5 of those. Really, the first 2 should be enough, but... right, import data list is suffix of. Yeah, I'm gonna have to write node here as well. Yeah, so see, ZZZ, the loop starting at AAA only goes to ZZZ. It doesn't visit any other A's, actually. Oh, it never even revisits A. That's interesting. Ah. So it's not a complete loop. There's some prologue before it gets into the loop. Oh, okay. But this is just a math problem. This is not... I mean, So what's another example of something that ends with A? BJA. Ah! I hit Control D too many times. Sorry, what was it? BGA? BJA, okay. So say we started here. Went to BJA. And it goes from BJA to TMZ and then stays at TMZ. It never goes back to an A or to its starting, any A's or its starting thing. And it gets into a loop that doesn't touch any of the space that the others are using, right? This is important. MLA. I just want to check that this is true for all of them. MLA goes straight to KPZ. We already do BQA? Nope. goes to BDZ. MJA and TGA. There's some curious... What's the last one again? TGA. Some curious similarities between these names. Right? Maybe? I don't know. Maybe I'm just imagining it. So yeah, each of these is in its own completely distinct subset of the input. So there really aren't like 24,000 to the sixth. There's like 24,000 over 6, so like 4,000 to the 6th, but that's still way, way, way too big. Assuming we use all of these nodes. There's too many total states that the system can be in, I think, to just explore them in the dumb way. So this reminds me of a problem in one of the first couple years, maybe 20. It was the year I was doing it in Python, actually, wasn't it? Would that have been 2016? No. Maybe. 2018? Yeah, I mean, Python is not a language I'm strong in. I was using it to try to learn Python because I thought I might need it for work, but it ended up I didn't. Anyway, there was this problem where, you know, there was a bunch of stuff to work through, but the core of the puzzle was, you know, find a number that's equal to 0 mod some prime, and equal to 7 mod some other prime, and equal to 15 mod some other prime, and equal to 72 mod some other prime. And that's what this is, right? The time that it takes to get to ZZZ the first time is what we need to be equal to. And the length of the loop from ZZZ back to ZZZ is what we want to do that mod. What prime, or you know, possibly prime, possibly some composite number, is supposed to be our modulus. And then we have 6 such problems, and we need to find a place where they all line up. The first place where they all line up. Maybe we'll go on a little adventure here. What day was that? I mean, it'll be on my GitHub, surely. The problem is, I don't know what year. Not 2016, surely. Repositories. 2016. Advent of Code 2016. Was this in Python? It was. Okay. The problem is, I still don't have any damn idea which problem it was. Wasn't it like mentioned slots or something? No, I don't know. Advent of Code 2016 Prime Chinese Remainder Theorem. Which day was that, please? Day 15? Yeah, that's probably right. So let me just make sure this is the right one. itertools parse solve. Yes. So I will show you this. my Python solution from 2016, day 15, where, yeah, so it says this disk number, whatever, has this many positions. At time 0, it's a position, whatever. So I reduced with combine the constraints. Oh, yes, and I sorted by... I wanted to do the biggest ones first, I remember. Because this while loop... You know, the problem of dividing modulo something is... I believe it's one where the best thing we know how to do is just guess and check. So I wanted the... I don't know. Am I doing sorted? Yeah, the biggest ones first. Because those are the ones you'll have to iterate through the most times. But I'm not sure. Maybe it didn't make a difference. The point is... if you have a constraint that some number must be congruent to n mod p and congruent to m mod q, assuming those are both prime, then you can combine those two into a single constraint that it be equal to x mod p times q, where x is, I don't totally know what exactly. Like, you basically just take n and you add p over and over until you find out, oh, look at this, it is the right thing mod m. And this is guaranteed to happen for 2 primes. So this is the kind of problem we're sort of solving now. And I don't know if you actually have to do the Chinese Remainder Theorem again, or if you could just simulate the whole thing. Do I really want to, like, implement this again? It came up again in, like, 2020 or something like that. I mean, you know, once every 4 years, you can't get too mad or anything, but... it is putting me to sleep. Because I'm going to have to, like, go collect for each of them what the mod is and what... I mean, it's pretty easy to do that. Right? For each one, you just... for each... yeah. Okay, well, maybe let's just do it the efficient way, whether that's necessary or not. I guess we'll find out when we get some comments on the video saying, I just did it with a brute force and that was easy. Why did you waste so much time? That's what you guys sound like, you know that? We're doing it for the beauty of the problem, not because it's got to be efficient enough to get done today. Although there was one that somebody... which one was the one that I did efficiently? Not the... oh, the range-based one. The soil and the seeds and so on. Where I estimated it would take, you know, 100 million times longer if you did it the inefficient way or something. And people had brute force solutions that were, you know, heuristic guided to be good enough or something. But at least one viewer on the channel did comment and say, oh, I'm watching your video while I let mine run, just doing the brute force way. And then they commented again and said, well, 2 hours later, it gave me the wrong answer. So maybe I'll try writing it so that I can get feedback a little faster. So that was nice to hear. That there was at least some reason to do things efficiently. So, part 2. We probably will need this. So we need the directions and the... honestly, I don't need the directions, do I? All I need is the input map to pass on to walk, and a list of nodes that I can do stuff with. So let's start writing some lets, shall we? Let starts equal filter ends with a m dot, surely it's called keys, where ends with S is Sn is S node of n is S is suffix of n, and we need to import that from data list. In. Well, we don't really want an in yet. We're not ready for that. But if I just did this, at least it would indent right. There we go. We have our starts. I guess what I want is a function that returns let's define a countersaint? Oh no, the countersaint is here. A constraint is constraint of modulus and remainder, both of type int. Deriving show. I want a function that, given a starting node, tells you I guess technically, well, this whatever, it's fine. Gives you back a constraint. Like, let's just call it constraint of start is let's see. We're gonna have to do some stuff. Steps equal walk start I. So we've now got all the steps it'll ever take. And we have to use like span or break or something. What exactly is the difference between those two again? Span. A tuple where the first element is the longest prefix that do satisfy P, and so break is the opposite, I guess. Previous prefix did not satisfy P. Prefix that don't satisfy P. Okay. So that's what I want then. And where is this data list? Actually, how would I know? No, it looks like it's in the prelude. Okay. Prefix. Well, goal rest, I guess, is break of ends with Z. So this will give me prefix, which is how many steps it takes to get to the first z. Then it'll give me the z that it got to, and the rest of what happened after that. It's a little annoying that it includes what it got to, but I guess it's fine. So I can already return length of prefix as the modulus. No, the remainder. Because we know it's about to enter length of a loop of length p. We don't know what p is. We're assuming it'll be prime, but we will have to check that. And we know that it took prefix steps to get there. So it must be equivalent to prefix it must be equivalent to prefix mod p is how is the constraint we're going to have. But now I have to find out how long the loop is. And that loop should be the length of, I guess we're going to break ends with z again on the rest. And I think we have to add 1 to the result because we stripped the goal off. In constraint of length loop plus 1, and now we could write prefix here, or length prefix. I'm not sure about that. Because we might want to reduce this. I think what I'm going to do, though, is just have part 2 output, like, a list of constraints. And we're just going to look at those in the terminal and see which of those first of all, do those make sense? But like, let's see what they are. Stack run. Okay. Wait, why is there a oh, right. The first part of the tuple is the solution to part 1. Ah. Really? All of these have exactly the same length of loop. As the prefix. That's a big surprise to me, right? It suggests, well, first of all, it really simplifies the solution. But it's, the fact that it didn't go back to A at some point, to its starting point at some point, made me say, okay, there's like a prefix of some length and a loop of some length, and there's no particular correlation between those two things. If it went back to A, we could say, okay, there's, you know, There's definitely a loop that includes the start and end, and some of that is... But okay, anyway. Huh. Well, in that case, I think we can just multiply those numbers together and get the answer, right? Assuming they're coprime, which... I mean... They look a little prime. I could go for a prime right now. Right? No easy divisible by 2 or 5 or 3 in there. So it's probably prime. I think those are the only composite numbers. Well, I mean, okay, let's try it, I guess. Just see if it's the right answer, and then product map modulus, I guess, since the modulus and the remainder are the same. Couldn't match type constraint. Oh, because I didn't actually call... There. Now, what is this thing about pairs of nodes? Oh, yeah, because this could be empty. That's a good point, actually. If this were empty, it would crash. Whoops. But it can't be? This is never empty. Anyway, if I say stack run, what do I get here? Like, let's just punch that bad boy in and see what the answer is. Oh, it's negative. Oh, no. Yeah. Where do I call length? Generic length, the worst function ever written. Just don't use it. If I used integers, would I get a good answer? I mean, I guess this can't be right. Because, there's no way you can type that in. Yeah. Okay, hang on. Maybe I just didn't even read the problem thoroughly. Follow them until they all simultaneously end up on Z's. Go left, so we're on 1, Z, but then we do walk away. Yeah, okay. So... There's just... I just feel like there's zero chance that they want me to type this number into Advent of code. So probably something else needs to be done. And so the first thing that occurs to me is like, what's... Wait, why did I multiply them all together? Oh, that's what I wanted, right. But... Oh, how do you find the least common multiple? Least common multiple. You can use the prime factorization method or list the multiples of each number. That's what I want, right? What is the least? How do you find? Okay, Wikipedia. Save me, Wikipedia. And arithmetic. Oh. The LCM of them is the smallest positive integer divisible by both of them. That is what we're looking for. It's least common multiple of the denominator of two. Okay, yeah, but I don't care about that. Yes. So like, how do people do it? Gears problem. Yes, this was the way that the 2016 problem was phrased. Basically, was a gear meshing problem, except it was like slots. Calculation. Oh, I see. I was like, yeah, these are equivalent, but yeah, this way you don't have to multiply until you've already divided. So you need the GCD first. And the GCD is very easy to compute. I mean, you know, there must already be one in Haskell, right? Is it in base, or do I have to import something? It's in base. Why am I even looking this shit up? Okay, great. So then, instead of product, I really should be able to say fold R LCM 0. I mean, okay, yes, fold R is maybe not the right function, but it's a very small list. It'll be fine. Any chance we get a different number here? Oh yeah, 0 probably meant, I meant to write 1, but then I said 0 instead. Okay, so that's actually a much smaller number. There is some common factor that they have in common that was not obvious to the naked eye. That's good. So is this correct? It's very large. It's the right answer, though. Okay. So it is there to discourage you from doing the totally brute force thing. I'm a little bit disappointed, but at the same time relieved, of course, that the length of the loops is always exactly as long as the length from the start to the start of the thing to the start of the loop. Even though those two don't, it doesn't then loop back to the start. That's just a big surprise, right? That's clearly done on purpose. But okay, to really genuinely solve the problem as stated for all possible inputs, we should do more work than this. Because the modulus and the remainder might have been different, and then this wouldn't work. How much more work would it be to make the solution correct, and do I want to put in that work tonight? Well, okay, let's start with a little celebration anyway. Day 8, part 2. Great, we did it. you would... I don't know. It just looks like a lot more work. I'm not going to do it. But if we're going to take advantage of this anyway, we might as well throw away all the hard work we did here, right? Instead of like looking at modulus constraint. I mean, okay, so I'm like getting highway blindness here. For each of these, I want to solve length, walk, no. Take while not ends with Z. Of walk I. No. Flip walk I. Where's ends with? It's right here. Parse error on where? Okay. Oh, and this, I don't need modulus anymore. Now I've lost my K, back to ints. So this all still, it's back to compiling. Is it still right? Yes, that's the same number we got before. Okay, so I mean, day 8, assume the loops are the same length as the prefixes, which simplifies the calculations, obviously. Huh. That's a little weird. I mean, you could just like write this in without knowing it's correct, and it would be correct, of course. Sort of true for everything, right? But I feel like this is the kind of thing that people might do without really thinking too hard about it. Is say, okay, they're just gonna assume the loop is gonna be this long. I went to the trouble of figuring out whether the loop actually like visits any other Z's or goes back to any A's or whatever. And that could be a more difficult version of the problem. But okay, we investigated and found that the loops are always the same length as the prefix. So all you need is their LCM. Fine, I'll take it. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.